In this video, we're going to briefly review the toolkit that comes with our machine. We do get several questions every week, customers asking about different tools for different applications. So we're hoping that this video will help bring some clarity to that. So as you can see, in my tool database, I have an iCarver General Toolkit 40-928. That's the toolkit that we sell as an option to our iCarver series machines. And in ArtCAM Express from 2013 and newer, any version after 2013, that iCarver General Toolkit is actually listed in your tool directory. If you're using an older version, 2012 or older, then that's actually needs to be added. But after 2013, it was automatically included in the tool database with the ArtCAM Express that comes with your machine. Now, as you can see, there's a list of the tools that are with the kit. You'll notice that one of the tools is actually listed twice. The 1/32 radius engraving tools. These tools are identical, just happen to be listed twice. So we're just going to look at each one of these individually. We're going to look at its applications. We're going to discuss briefly its applications, as well as look at a couple settings that you might want to consider changing from time to time, depending on the type of machining operation you're doing. So let's start with the general iCarver Conical V-bit 1/32. This is the tool that comes with your machine. There's also a second one of them if you've purchased the 40-928 toolkit. Another one of them comes with the toolkit. And the reason is because it is a tool that's used quite often. And we find that it's one of the best engraving tools that we have seen. You'll notice if I click on Edit, there are two settings that you may want to consider changing from time to time. One is called Step Down. You see it right here. You can see that our step down is set at 0.25 inches, which is a good default setting for this tool. It means that it's going to machine a 1/4 inch per pass. So if I'm machining a total 1/2 inch depth, it's going to machine it in 2 passes. The other setting to consider changing is what we call step over. In this particular case, our step over is set at 0.01 inches, or 1/100th of an inch. That's a pretty good setting for this particular tool. It's pretty fine detail. If you needed to get even finer detail or trying to eliminate even more machining lines, you may set that number even lower, maybe 0.007, 0.006. If you're not as concerned about those machining lines, then a slightly higher number, 0.02 perhaps. But generally speaking, 0.01 is a pretty good setting for that tool. So that is the 1/32 Conical V-bit. You'll see that there are two up spiral end mills listed, an 1/8 inch right here, and a 1/4 inch right here. And these are, up spiral end mills are typically used for doing clearing areas. So I'm going to clear out a center portion of a coaster as an example. Then I might use a 1/4 inch or an 1/8 inch up spiral end mill because it will throw the material out of the wood. You'll also see that we have down spiral end mills listed as well. There's an 1/8 inch down spiral end mill. Down spiral end mill would be a tool that would be used if you were going to machine a fine edge. So if I'm going to machine the edge of, say I'm cutting out a part, maybe I'm cutting out a cloth here, I'm concerned about the tear out at the top of my material, so a down spiral end mill will tend to force the wood chips into the material and thereby giving me a better finished edge. You'll see that below that there are two Ballnose cutters, 1/8 inch and 1/4 inch Ballnose. Ballnose, like the Conical V-bit, would be used for doing 3D modeling. Now, where I would use a 1/4 or an 1/8 inch Ballnose instead of the 1/32 bit is if I was doing something that didn't have so much detail, but I was looking for a nice finish. I wanted a good smooth finish. So the larger the tool, the better the finish. You get less machining lines typically. Now, I want to just make note of one setting that with end mills and Ballnoses you may want to consider adjusting. You can see here we set the step down on this particular 1/4 inch Ballnose at 0.125 inches. In other words, an 1/8 of an inch. So it's half, the step down is half the diameter of the tool. That's our general rule of thumb when it comes to machining. We like to machine about a half the diameter of the tool. It tends to make the machine not work so hard, and it also tends to it reduces the wear on the tools. And it also tends to give a much better finish as well. So that's one setting. If you were in a very dense wood, you may want to set the step down a little bit lower. Again, if you're doing a softwoods, maybe a pine, you could potentially get away with setting the step down a little bit deeper. The general rule of thumb is those settings are pretty good. You also see that we again have that step over option available to us. So if I'm doing a large clearing area and I'm not as concerned about finish, then I may set that step over as high as I can get it. General rule of thumb is you never want to have a step over more than 50% of the diameter of the tool. In other words, a 1/4-inch Ballnose cutter, for example, or a 1/4-inch end mill, the largest step over that I would want to have might be 0.125, and so on. Again, the tighter that step over, so the lower that number, the better the finish that you're going to have. So if you're clearing a flat bottom on a sign, for example, and you want to make sure that's super smooth, then set your step over low. It will take longer to machine, but you're going to get a very nice smooth finish when you're done. So we'll just close that. Then the last two that you have is the 60 and 90 degree V-bit. They tend to be used for carving work. If you're doing V-bit carving toolpaths, you'll use 60 and 90 degree V-bits. You can also use them to do beveled edges, for example, on the side of a plaque or a sign, and you want to create a beveled edge on the outer border. You could use it for that. But typically, the 90 and 60 degree V-bits, the biggest application for those is usually doing carved signs. Of course, the difference in the geometry means that you've got steeper angles. A 60 degree V-bit will give you steeper angles. You can see if I click on it, you can see that the angles here are much steeper than the 90 degree V-bit, so it tends to give you a very different look, and it really is very subjective. It really depends on what you're trying to do with that particular project and what the expected outcome is. So that's the 8 pieces in the general iCarver toolkit, 40-928, and basic use of the tools and their various functions. There's certainly lots more to learn about tooling as you get more accustomed to your CNC machine, but as a general start point, that gives you a basic understanding of how the tools all work.